Hello everyone, welcome to Vision classes. It's a classes for IGCSE, GCSE and AS and A level student around the globe. Today we have to discuss the syllabus of Cambridge O level physics 5054. It's the subject code, fine. And this syllabus is for exam 2026, 27 and 28. All right. If you look at the previous syllabus and this syllabus, there are just only few changes are there and we will discuss at the end. Before we jump on to the content overview, I am Dhanraj Sir, teach Cambridge Maths and Physics. So suppose if you want to connect with us, I have left the contact in the description box. Our classes, regular batches are going on continuously and we are here to help the student to get his or her best. Fine. Here, the next part, we have papers. So you have the content overview. We have a 6 topics are there. First one is motion, forces and energy. Then next one, thermal physics, wave physics part, electricity and magnetism, nuclear physics part and space physics part. This is just a 6 parts are there, and from each and every topic you will get the question. That's it. So you have a 3 papers to give. First one is paper 1, multiple choice questions, and it's a 40-mark question. It will be having 30% weightages there. Then next one, paper 2, it's a short answer and structured questions will be there, and you have to write those answers, solve the questions, okay, numericals, and it will be having 50% weightages there. And third one is the practical assessment. Is the either you can give the practical test or alternative to the practical paper. All right, and this is just a again easy part. So whatever the practical you have performed throughout the year, you will get the questions on this part. Isn't it easy? So nextly, here we have subject content. First part is motion, forces and energy. You will be having 8 topics are there. Okay, so 8 topics, such as first one is physical quantities and measurement techniques. So you have a scalar, vector. Then nextly, basic quantities such as distance, speed, time, mass, energy, temperature. These are even scalar quantities are there. Vector quantities such as displacement, forces, weight, velocity, acceleration part. All right, then momentum, electric field strength and the gravitational field strength. Okay, so nextly, here motion. In the motion you have to discuss the differences between the distance and displacement, speed and velocity, acceleration part, and then graph based questions also there. Then you have a shape of distance time graph, then shape of speed time graph, and you have to assess, analyze the when the object is at rest, when it is moving, and moving with constant acceleration and changing acceleration part. All right, then nextly, the speed in the form of gradient of distance time graph. Okay, and calculate the acceleration, that is also part of the motion. All right, then next one, mass and weight. So you have to understand here difference between mass and weight, difference of weight in different planet. Okay, how weight and mass changes. Okay, then nextly, density part. Density is mass per unit volume, and its numericals are there. Its a unit is there for your syllabus. So for MCQ you have to just objectively prepare this physics part, each and every topic, and for short answer and long answer question type you have to prepare it thoroughly, little bit in depth, and even I would say point to point you have to note down each and every other topic. Suppose if there is in the paper you have a question, short answer, long answer questions are there. So always keep in mind that you will get one question at the beginning, what's a, let's say, density, and from the density you will get the numerical question. So these kind of structured questions you will get in the paper. Fine. Then nextly, forces. So we have a unbalanced forces, balanced forces, then different types of forces are there. Okay, gravitational, frictional, drag force, resistance, tension, then electrostatic, magnetic force, thrust and contact force. These forces you have to understand their examples, how they are utilized. So resultant force is nothing but mass times acceleration. So here even you have to understand the Newton's laws, third law, all right, third law, their example, how we can apply them. Then nextly here we have to understand the friction and their impact, okay, consequences. Then nextly you have to define the thinking distance, braking distance, stopping distance, their definitions, all right, factor affecting those distance, okay. Then elastic deformation, here even you have to define the spring constant, which is force over extension. And again you have a graph is there, so you have to understand this spring constant part thoroughly. You have even numericals are there on this part. K is equal to F over X, all right. Sketch and plot the graphs as well. Then nextly circular motion, motion in the circular path, increase in speed, then radius decreases, how it affect, all right. Then turning effect of forces, so it's a generally nothing but movement, how this movement is utilized in even day-to-day life, all right. Then principle of movement of the object in the equilibrium, verify the principle of movement. Then nextly we have a center of gravity, determine the position of center of gravity of plane lamina, right, effect of position of center of gravity. Then nextly we have a momentum, momentum is nothing but mass times velocity, again you will be having numerical questions. Then conservation of momentum, okay. So nextly you have a energy, work and power. Energy, work and power, you will be having kinetic energy, gravitational energy, chemical, elastic, nuclear, electrostatic and internal thermal energy part is also there. Then you will be having numerical question on kinetic energy, then gravitational energy. Here you have a work done concept. Work done is nothing but force times perpendicular distance or distance moved by the object, okay. Then energy, all different types of energy concept here. And what are the different types of examples for this one? So for example, chemical energy, from where we will get the chemical energy, you have to think how we prepare or produce the solar energy, geothermal energy, their concepts, fine. Some diagrams are there, you have to understand them. So their advantage and disadvantage is very important part. You will get the 2 mark question, write the advantage disadvantage of, let's say for example, geothermal energy, okay. So you have to write more specifically point of point form, then and then you will get the 2 marks, all right. Then efficiency, efficiency is nothing but useful energy output over total energy input, okay. And you put efficiency of any system is always less than 1, you have to understand here. Then power concept, power concept is nothing but work done over time taken, okay. Then last one, it's a pressure, pressure is force per unit area. So pressure in the liquid and pressure in general normal object or in the even air we have to understand. So change in pressure is density, gravitational field strength, and change in height, okay, rho g h. So these concepts are there, and based on those concepts you have to understand even numerical questions, all right. Then second topic we have, that is thermal physics. Thermal physics part, you have three topics are there. One is the kinetic particle model of matter. So you have to understand the properties of solid, liquid, gases, how they behave if temperature goes up, fine. Then nextly, so here we have to understand even relation between the pressure and temperature, volume and temperature, pressure and volume, okay. So here some laws are there, you have to understand those laws as well, and you have a numerical on those laws. Then nextly second part is thermal properties and temperature. So thermal properties, you have a application and consequence of thermal expansion. Then you have some experiments also there, all right. You have to understand the difference between the Kelvin and degree Celsius. Then nextly specific heat capacity, specific heat capacity concept is there. So amount of heat required to raise the 1 kg of material by just 1 degree Celsius is nothing but specific heat capacity. And based on this you will be having even examples are also there. Then melting point, boiling point, and then evaporation, what are the factor affecting the evaporation, you will be having there for the syllabus. Okay, then nextly third part, that is transfer of thermal energy. So we have a more specifically three modes of transfer of thermal energy are there for syllabus. One is conduction, convection, and radiation. So how they transfer, their factor affecting those transfer of energy we have to understand. Then consequence of thermal energy transfer we have to understand. That's it. Then next part is wave physics. Wave physics, you will be having four topics. General properties of wave you have to understand in first part. So even features of waves such as wavefront, wavelength, frequency, crosstalk, amplitude, wave speed. Then we have to understand the frequency, wavelength, amplitude. Then wave equation is wave speed is equal to frequency times wavelength. We have, then we have to understand the reflection, refraction, diffraction concept. Okay, so you have to even use these concepts for ripple tank as well. All right, ripple tank concept experiment is there, even you have to do this experiment in your school as well. All right, then next part is light. Okay, so waveforms of light you have to understand, the how they behave when they strikes on the surface of mirror glass. You have to understand when they changes from the one medium to another medium. So you have to understand angle of incident, angle of reflection concept. Here laws of reflection is also, law of reflection is also there. All right, then some of the construction or sketching part is there. Okay, different diagrams are there, reflection of light. Okay, then you have to understand the critical angle, total internal reflection. Fine. Then thin lenses. So here you have to understand the thin lenses such as converging and diverging lenses. Okay, how the rays are formed. All right. So nextly, linear magnification, image length over object length you have to understand here. Then nextly, dispersion of light. Okay, dispersion of light concept and numerical based on this part also there you have to understand. All right, then nextly, next part is electromagnetic spectrum. So electromagnetic spectrum, you have a following components such as radio waves, microwaves, infrared rays, visible light, ultraviolet rays, x-rays, then gamma rays, and their applications are key because you will get 1 marks 2 mark questions. Okay, generally. Then nextly, damage caused by the electromagnetic radiation also you have to understand. And last part is sound. What's a sound? Then sound waves describing their compression and rarefaction. So audible, human range as well, there you have to understand. Then different sound sources. Okay, so what's a echo, right? You have to understand. Then speed of sound generally. Okay, so ultrasound and their applications we have to understand. Nextly, fourth topic, that is electricity and magnetism. So you have a six topics. So first part is very simple, that is magnetism and magnetic field properties. So what's a magnetism, what's a north pole, south pole, their properties. Okay, then nextly, what's a permanent magnet, what's a soft magnet or permanent magnet you have to understand. Then nextly, electric charge, unlike charge attract, like charge repel. So these are the properties that you have to understand. Then electric field pattern. All right, then nextly, examples of electric conductor, insulators. All right, then nextly, electric current concept you have to understand. In the electric current concept, you have a charge over time, q over t, and application or questions based on this part. Then movement of free electron, difference between direct current and alternate current. Then state the conventional current. All right, use of ammeters with different range. Nextly, electromotive force as the electric work done by the source. Fine. Then nextly, E is equal to W over Q. All right, then V, work done by the unit charge passing through the component. V is equal to W over Q. Then we have to understand and solve the numericals on this part as well. Then nextly, we have a resistance, R is equal to V over I. Again, here we have a numerical on this part. You have to understand the Ohm's law. You have to sketch and explain the current voltage graphs as well. So effect of temperature on the increase in resistance. Fine. Nextly, electric circuits. So electric circuit, we have to understand the different components such as battery, cell, power supply, generator, oscillators. All right. Then lamps, motor, ammeter, voltmeter, how they are connected in the circuit, we have to understand. Then we have a series and parallel circuit. So combination of resistance of two or more resistors in the series and parallel, we have to understand their diagrams, okay, numericals on them. Then nextly, we have a action and use of circuit components. Then use of electricity. So here we have a power concept, that is current times voltage. Energy is equal to current times voltage times time. Okay, so we have even understand the kilowatt concept. Okay, calculate the cost of using electrical appliances, we have to understand. All right, then electric safety measures. So damaged insulation, overheating, damp. Okay, even here we have to understand the earthing concept as well. All right, then electromagnetic effect. So here you have to understand the electromagnetic induction, AC generator, magnetic effect of current, then forces on the current carrying conductor, and DC motor. So DC motor, and then lastly transformer. These are the things or six concepts that you have to understand under the electromagnetic effect. All right, and then lastly, use of an oscilloscope. So oscilloscope display the waveform. We have to just understand, this is very simple and short concept. Then comes nuclear physics part. It's one of the interesting. You have just two topics are there. So in the nuclear model, firstly we have to understand the atom. Okay, atoms, electron, proton, neutrons. Okay, then alpha, beta, gamma particle, then nucleus. So here you have to understand how we can note nucleoid notations are also there. All right, then next part is radioactivity, detection of radioactivity, alpha, beta, gamma particles. So we have to even understand the background radiation, how to measure the background radiation. Then we have a three types of emission, alpha, beta, gamma radiation part is also there. Then nextly, radioactive decay, fusion and fission process is also there. Their definitions you have to understand. Then next one is half-life concept, and we have to understand lastly safety measure required for the nuclear radiation. Okay, these are the parts are there for nuclear part, nuclear physics part. Then space physics. So recently this space physics part is added in the physics part. Okay, so the space physics, because these days we see lot of exploration of spaceport. Many countries are actually exploring the space. So we have to understand the space part. Fine. So in the space part, you have to understand the firstly different planets. Fine. So how they rotate, their approximate distance. Then we have to even calculate here orbital speed using v is equal to 2 pi over r over t. Then solar system, we have to understand stars. Fine, 8 planet. Okay, then nextly minor planets are there, moon, orbit or planets, then smaller solar system bodies. All right, so interrelated concepts are also there. Then nextly, sun is a star of medium size. Fine, and how stars are formed, we have to even understand. Here you have a next part, that is star. Okay, how stars are formed in the galaxies. Okay, astronomical distance, what's astronomical distance, we have to understand. Interstellar cloud, then protostars. All right, then how all star eventually run out hydrogen as a fuel. Okay, and their nuclear reactions are also. Then nextly, red giants from the star, right? Then red supergiant explodes, then nebula forms, supernova. These are the concepts are there, we have to understand in this part. Then nextly, universe. In the universe we have a Milky Way, right? So Milky Way related concepts are there. Okay, these are theory part. Fine, and we have different aspects of theory part are there, because we have in the galaxy or in the universe, actually we don't know many things still. But here, for our understanding purpose, here just we have to understand few things about the universe, how stars are formed, how means the star vanish in the universe as well. Okay, that's it, fine. I hope you understood the all the topics relating to the O level physics. Fine. Just understand that all candidate take the three paper, and all three papers assess the grade A star to E. A star is maximum one, E is lowest one. All right, that's it. I hope you got the basic idea. If you want to connect with us, I have left the contact in the description box. That's it. Thank you.